This video is about writing conditions for constructs like conditionals and looping structures. We'll talk about relational and logical operators. I'm using the ones from C and Java, but the ideas translate to conditions in other languages too. These are the basic relational operators. Notice these things. In C, these evaluate to 1 or 0. That's because anything that is not 0 is considered true, and 0 is considered false. In Java, they evaluate to true or false. For the rest of this video, when I say true, I mean 1 in C, and when I say false, I mean 0 in C. An equals comparison is 2 equals signs. In C and Java, that distinguishes it from the 1 equals sign that is used as an assignment statement. Not equals is an exclamation point, which we call bang, so this is often read as bang equals. Greater than or equal to and less than or equal to are coded with the equal signs after the comparison. We can use these logical operators to combine things that are true or false. Logical AND is 2 ampersands and will evaluate to true only if both of the operands around it are true. Language designers picked AND as the name of this for a reason. Similarly, logical OR is 2 vertical bars and will evaluate to true if either of the operands is true. Finally, the exclamation point, bang, is logical NOT. Essentially, it inverts the truth value of its operand. Let's look at some examples and play with these a bit. Coding a conditional that expresses that a variable is between 2 values can't be done the way we did it in math class. Instead, we have to code the 2 ends and AND them together. We want something that is true if x is in this part of the number line. We can get that by checking if x is greater than or equal to 3 and it is less than or equal to 6. It is between those values only if both of the conditions is true. I like writing the relationships this way because it shows that x is between 3 and 6. Clearly, there are other ways you could write expressions equivalent to this. Checking for not between is a bit different. If we were checking that x is not between 3 and 6 and not equal to them, we wanted our expression to be true if x is here or if x is here. So we code that with a logical OR statement. Like before, I like writing the relations in this order because it shows that x is outside of 3 and 6. A lot of times, it's easier to think of the opposite of something before we can think of something. For me, thinking about betweenness is easier than thinking about not betweenness. When that happens, we can use DeMorgans Laws to simplify our conditions. He gave us 2 laws. I'd read the first one as, the opposite of an AND is the OR of the opposites. Let's think about that for a minute. For A and B to be true, both A and B must be true. So for not A and B to be true, A and B must be false. For A and B to be false, at least one of A or B has to be false. He also gave us the opposite of an OR is the AND of the opposites, and similar reasoning shows why that's true. We need an example to show why we care about this. I said it's easier for me to think about betweenness, so let's start with that and derive not betweenness. So, for x to be between 3 and 6, 3 must be less than or equal to x, and x must be less than or equal to 6. I can get not between just by putting an exclamation before that. But that's pretty yucky code. Let's use DeMorgans Laws to simplify that. This is the opposite of an AND, so it is equal to the OR of the opposites. Still not pretty. Let's keep working on those nots. If 3 is not less than or equal to x, then 3 must be greater than x. Notice the opposite of less than or equal to is greater than. Similarly, if x is not less than or equal to 6, it must be greater than 6. For readability, I can reverse those 2 relations and get back to the one we liked a couple of slides ago. So, if a condition is hard to code, try thinking about the inverse of the condition, and then negate it and use DeMorgans Laws to clean things up.